Yes, now we were, I am being told that there was one question number 14, which I did on that particular day, but it was not merely finding the derivative, it was to be shown something. So I am taking it once again. It is question number 14 of your miscellaneous exercise. It is x under root 1 plus y plus y under root 1 plus x is equal to 0, and you have to show that its derivative is equal to minus 1 plus 1 upon 1 plus x whole square. Okay, see, this is a bit tricky question. Here what you need to do is, and this is what we did earlier also, that this thing you can well write to be minus y under root 1 plus x. You square it up and you will get x square 1 plus y is equal to y square 1 plus x. Now this thing, when you will open it up, you will get x square plus x square y is equal to y square plus y square x. Now this term you bring on the one side, x square minus y square, and this term you please bring on the other side, and better you y square x and minus x square y. So here this is nothing but x minus y, x plus y. Now you take, if you are taking minus sign common here, and not only that, you are taking xy common, so what you will get? From here you will get x, and from here you will be getting minus y. Now see, x is not equal to y. X is not equal to y, because if x would have been equal to y, then see, this equation would have been entirely different, and there was hardly any need of this y being expressed in terms of x, because it is an implicit function and you have to find the derivative. So naturally y has to be some function of x. It can't be equal to exactly x. So we are justified in cancelling this thing, and what you will get is x plus y is equal to minus xy. Okay, so now this thing will give you what? Please see, y this term you bring on the one side, and this other term you can keep on this thing. So here you take y common, you will get 1 plus x is equal to minus x. See, minus xy we have brought on this side. So y plus xy, we have taken y common, so we will get 1 plus x is equal to, and this x we have transposed on the other side. So with this thing, now we will see that y is equal to how much? Minus x upon 1 plus x. Now see, getting the differentiation of this thing is an easy task. I will do it on the top so that you can nicely look into it. So y is equal to minus x upon 1 plus x. So it is, so dy by dx or y dash is equal to how much? See, it is in the quotient form, so obviously it is 1 plus x, denominator is square, 1 plus x into derivative of denominator, that is minus 1, minus numerator, numerator is how much? Minus x, okay, and derivative of this thing, it is 1, 0 and x is 1, so it is 1 basically. So what you are getting is that it is, what you will get is minus 1 minus x plus x upon 1 plus x whole square. This thing will be equal to, this x will cancel and you will get minus 1 plus x whole square. So this is how you will find the derivative of this. This is what you really wanted to show it. And I am being further told that there was some mistake which we have done in the solution of one particular question, and that was the question number, this one. It is question number 9. Question number 9 is, we will revisit it and I will tell you where we add, and this is sin x, it is y is equal to sin x minus cos x raised to power, how much? Same thing, sin x minus cos x. Okay, sin x minus cos x. Now see what you are taking log both the sides, so log y will be equal to what? Sin x minus cos x within the brackets and log of this whole thing, same thing, sin x minus cos x. Okay. Now differentiating both sides. So when you will differentiate log y, it will fetch you what? 1 upon y into y dash. Should I explain you how it comes? Okay. So d upon dx of log y, you will write this thing d by dx of this whole thing. Okay, d by dx of this whole expression, which is the product of two functions, first function and this is the second function. So this is now what you will do, you will take d upon dy log y into dy by dx. And d by dy of log y is what? 1 upon y. So 1 upon y dash is equal to, now please see what it will fetch us. It is, we will apply the product rule. And this thing, first function, what is our first function? It is sin x minus cos x in one bracket and the derivative of this thing. Differentiation of log sin x minus cos x will give us what? 1 upon, first of all this whole thing you will put t. So derivative of log t with respect to t will fetch you 1 upon t, that is 1 upon sin x minus cos x and the derivative of this whole thing. So derivative of sin x is what? Cos x and this is what? Plus sin x. Okay, and so first function derivative of second plus second function log sin x minus cos x. This is your second function and derivative of first, which will fetch you what? Cos x plus sin x. Okay, this much of thing you are getting. Now, what mistake we did that particular day was, in the next step, see, this is one thing. This is one thing and this is the other bracket. This log sin x minus cos x is one expression and this cos x plus sin x is something else. So now we can't multiply it because see that day I did it log sin square x minus cos square, which was erroneous. So we have to rectify that mistake. So it will fetch me what? 1 upon y dash is equal to, yes, this expression will remain as such, sin x minus cos x and this cancels rather. And what you will get is sin x plus cos x. Cos x plus sin x right now, sin x plus cos x hardly matters. Plus, now second expression, please see it is, now see this expression and this expression, here you can take common, here you can take rather common from these two. And when you are taking this thing common, what you will get is 1. From this expression cos x plus sin x you have taken common 1. Plus here what you will get is log sin x minus cos x, that's all, and within the brackets. And this y to be multiplied here, so y dash will be nothing but y. And what is the value of y? This whole expression sin x minus cos x raised to power sin x minus cos x and then this whole expression. Okay, sin x plus cos x and 1 plus log sin x minus cos x. This is the answer which you have to take it. Now see, we start with the further questions here. Let me take question number question number 10, please. Yes. If x minus a whole square, x minus a whole square plus y minus b whole square is equal to c square for some c greater than 0, for some c greater than 0, then you have to prove that 1 plus dy by dx whole square raised to power 3 by 2. See, what is given is here I am writing 1 plus y dash and y dash is square here, and this thing is well within the bracket, and this is 3 by 2 and this is what? Y double dash. Y double dash means d2y upon dx square. Okay, so let us see how we can do it. Let us differentiate this whole thing with respect to x. So what we will get? D upon dx of x minus a whole square plus d upon dx of y minus b whole square is equal to d by dx of c square. Now d upon dx of this thing will be what? It will be 2x minus a into x minus a you will put t square. So it will be d by dt t square into dt by dx, and t is x minus a, so dt by dx will be what? 1. So plus, now this thing, here you have to differentiate first of all with respect to y, and then dy by dx, okay, and this thing is 0. So it is 2x minus a plus, now this thing is what? With respect to y, again same thing, y minus b, you will put some other constant, say p, and then p square d by dp, p square will be 2p and into dp by dx, so 2y minus b into, and this p is y minus b, so dp by dx will be what? dy by dx. 2y minus b, okay, and that is 1, okay, is equal to 0. 2 cancels goes everywhere, and y dash you are getting equal to what? You are getting it equal to minus, please see, x minus a upon y minus b. This is what you are getting. Okay, let it be. Now, please put the values here. Now, put it, this is say 1. Okay, now this value we will like to substitute in this equation, and let us see what we are getting here. Okay, and initially, okay, y dash you have calculated. We have to calculate, okay, d2y also we have to calculate. Okay, so let us differentiate once again. So what it is? It is in the denominator quotient form. So what you will get is y minus b whole square, okay, minus you take it outside, so y minus b into x minus a, derivative of denominator, that is 1, minus x minus a into this thing, derivative of this thing, so it will be what? Y dash, okay. So this thing on simplification will fetch you what? It is y dash will be equal to then, please see, y minus b whole square, okay, y minus b in the numerator into 1 minus x minus a into this thing, y dash, and what is the value of y dash? It is minus x minus a upon y minus b. See, this is 2. From 2, we are putting the value of y dash here. We are putting the value of y dash. So what we will get is, now minus x minus a, y minus b, it is. So here at place of y dash we will put this thing. So y dash is minus, so that minus will make it plus, and x minus a and what else? Y minus b. Okay, so this is what we have kept at place of y dash, minus this thing, upon y minus b whole square, upon y minus b whole square. So this will give me what? Y minus b whole square. See, here we will take LCM y minus b whole square plus x minus a whole square upon y minus b raised to power 2 and then 3. It will be cubed now. So this is the value of y double dash. This is your y double dash. Now let us see. This is your y. This is, okay, this is 1, this is 2. Now let us put these values here. Let me shorten it. I will write here minus x minus a upon y minus b. This is your expression 1. Let me remove it so that I can have sufficient space. Now please see, we will calculate 1 plus y dash square. 1 plus y dash square. Y dash is this thing, it is square. Minus will become plus, so it will give me x minus a whole square upon y minus b whole square. 1 plus y dash square raised to power 3 by 2, it is 3 by 2 here, and upon what? d2 second derivative. And the value of second derivative is given here. It is y minus b square plus x minus a square is equal to c square. Please see, it is constant. So here I can well write to be what? It is c square upon y minus b cube. Okay, so it is c square upon y minus b whole cube. Okay, now please see what it is. Again see, within the brackets it is y minus b square plus x minus a square, which is again c square. See, this when you will add up, so what you will get is c square upon y minus b whole square raised to power 3 by 2 upon c square upon y minus b whole cube. Okay, and what you have to show that this thing is independent of a and b. Okay, this thing is independent of a and b. Fine. So what it is? It is c square under root c upon y minus b. So it will be c cube upon y minus b whole cube upon c square upon y minus b whole cube. This cancels, c square cancels here, and you are getting c. So you are getting a constant, and this proves your proposition. And this proves your proposition that 1 plus y dash square upon raised to power 3 by 2 upon d2y upon dx square, that is equal to, that is independent of a and b. So this is how you can show it. Now, next question. Yes. Question number 6b. Question 16, please look in. It says cos y is equal to x cos a plus y. X cos a plus y. Let's prove that y dash is equal to cos square a plus y upon sine a. So what you need to do is here, see this expression. Now see, common sense demands that let us segregate x one side so that the right side becomes entirely the expression of this thing. X is equal to, now see, I can rewrite this is equal to what? X is equal to cos y upon cos a plus y. Now I will differentiate both sides with respect to x. So what I will get is d upon dx of x is equal to d by dx of this whole impression. And this thing, let us write this thing. How this will be? Now this is in the quotient form. So you will apply the formula for the quotient form. So quotient form demands that what? Denominator is square. Okay, you write denominator is square here. Then denominator cos a plus y. And then derivative of numerator cos y. Please see, cos y is to be differentiated with respect to x. See, derivative of denominator will be what? D upon dx of cos of y. So this is what? D upon dy of cos y into y dash. Dy by dx or dy by dx. So this is minus sin y into y dash. Okay, so this is, at this value you will put here. So it is minus sin y into y dash. Please see, write this thing, minus numerator is your cos y, and derivative of denominator derivative of denominator, fine. So derivative of denominator again, see, d by dx of cos a plus y. Here again, see, this has to be written as d upon dy of cos a plus y and into dy by dx, which will be nothing but cos of this thing will fetch you what? Minus sin a plus y, and derivative of this thing a is 0, y is 1, so it will remain same into y dash. So minus, so it will become what? Please see, it will become plus here, and you will put sin a plus y into y dash. So this is how much you will get here. Now, please see. Yes. Here you will d by dx of x is what? 1. So 1 is equal to what? This thing you write here. So it is this thing. Now first you y dash you take common. So within y dash when you are taking common, then what you are getting? Please see, sin a plus y. Sin a plus y, this term we are writing first. Cos y minus cos a plus y sin y. And it is y dash upon cos square a plus y. So this is 1. Okay, no issues. So y dash, now this thing here, it is the formula of sin a plus b, a minus b rather.
a plus y minus y. So this 2 will cancel upon cos square a plus y. So this is 1 cross multiply and into y dash. So y dash will be equal to what? This thing gets multiplied here. It is cos square a plus y upon sin a. Sin a. And this is what you really wanted to prove. This is what you really wanted to prove. Next question, please look in. Okay, question number 17. Please see. Question number 17. Okay. If x is equal to, yes, a cos t plus t sin t and y is your how much? It is a sin t minus cos t minus t cos t. Okay. And then you have to find d2y upon dx square. d2y upon dx square. Okay. So now you know dy, when things are given in the parametric form, then dy by dx is nothing but dy by dt upon dx by dt. Okay. So first of all, let us calculate this dx by dt here. So d by dx or d by dt is equal to what? A is constant. Cos t derivative is minus sin t plus. This is the product of two functions, first and second. So we will, for finding the derivative of t sin t, we will invoke the product rule. So first function t, derivative of sin t, cos t plus sin t, and that's all. So this is sin t cancels. So this is what you will get is a t cos t. This is the derivative dx by dt. Likewise here, dy by dt will fetch you what? Here see again a sin t derivative cos t minus. This is again the product of two functions. So first function t, derivative of cos t, that is minus sin t. Please see, it is t, then minus sin t, and plus what else? Cos t and derivative of t, that is 1. Okay. So here, what we are finding is that this cos t, this is minus here, this is plus, so it will be minus plus t sin t a. Okay. So this is expression 1, this is expression 2, it is dy by dt, yes. Now see, therefore dy by dx will be what? By dy by dt is at sin t upon at cos t. So at cancels, you get tangent t. Okay. So this is dy by dx. You have to find what? d2y upon dx square. So what you will do? You will differentiate it once again with respect to x. Okay, let us see what we get is d by dx of tangent t. And this is what? D by dt of tangent t into dt by dx. Let us see. And tangent t is what? Sec square t. This is sec square t, please mind it. And this is dt by dx. From where we should get the value of dt by dx, that is to be adopted. We know from here, see equation 1 if you look in, then what you are getting? Here, please see. X is, okay, let me remove this one. Please see. Here, x is equal to a cos t plus t sin t. So let us differentiate this equation with respect to, you want x, dt by dx. So differentiate with respect to x, dt by dx. Okay, yes. So dx upon dx, that is 1, will be equal to 1a. Differentiating with this thing with respect to x, dx by this is cos t plus. Again, this thing has to be differentiated with respect to x only. So this will fetch me what? This is d by dt of cos t. Please see, it is will be d by dt of cos t into dt by dx. Okay, plus. Likewise here it will be d by dt of t sin t into dt by dx. dt by dx. Okay, this is. Now what this value will be giving me is d by dt is sin t dt by dx. Okay, plus here d by dt is product of 2. So as in the earlier case it will be t cos t and plus sin t only. Plus sin t. It is minus sin t. Please see, d by dt of cos t is minus sin t into dt by dx. Okay, into dt by dx. Okay, this whole t sin t and this whole lot is with respect to dt by dx. Okay. Now, please see. Here, this is your 1. This is your 1. So dt by dx, let us see what it will be. Here, see this minus sign, this thing will cancel. And what you will get is, here, 1 is equal to your, how much? Only this thing is left out. 1 is equal to t cos t into dt by dx. So the value of dt by dx will be what? 1 upon t cos t. Here, from here, it will be dt by dx will be equal to this much of thing. This much of thing. Okay. And this value let us put here. So what we will get is sec square t into dt by dx is what? 1 upon t cos t. 1 upon t. No, and a also. A is also there. Please see, a is also here. This is a is getting multiplied throughout. As a matter of fact, we should keep these brackets all the way. So it is 1 upon a t cos t. So here you put this thing. So what you get is this is now cos t. You can combine here sec cube t upon a t. That's the answer. That is the answer of d2x upon d2y upon dx square. So please see, this is the important question. And dx by dy by dx, of course, you can obtain by dy by dt upon dx by dt. But when you are differentiating this second times, then you have to be careful. Because this expression consisting of this was your d by dx tangent t. So this again has to be differentiated dt by dx, and this value has to be obtained from the first value. You can't obtain it by the y by the parametric representation of y in terms of t. Only with respect to x you can obtain this thing. Okay. So let's take the next question, please. Let me clear it. Yes. Yes, next question, please read all of you. Yes, this is question number now, which one? Question 18th. Question number 18, please see. Fx is equal to mod x cube, show that f double dash exists for all real x and find it. Okay, second derivative you have to find it out. Fx is having given to be equal to what? It is mod x cube. Okay. So this function, now mod x you don't know. So you had to reframe your this modulus x function. So fx can well be written to be what? It is x cube when x is greater than 0 or equal to 0. And this is equal to minus x cube when x is less than 0. So now this is your function. Instead of fx is equal to mod x cube, you can assume it that your function now is given this way. Because here these things have been given in different intervals by the polynomial function, and you know how to differentiate this polynomial function. You have already learned that.
Okay, so with this reframing of your function, let us see. Now, please see, for x greater than equal to, for x greater than 0. Now, see different cases. Case 1, fx is equal to x when x is greater than 0. Case 1 corresponds to x. So, there the function is x cubed. So, f dash x, you know, by the standard formula, this is 3x square. You have to find the second derivative or the first derivative. Show that the second derivative exists. Okay, then f double dash x will be how much? It will be 6x. Okay, so this will be the derivative in the case 1. Likewise, in case 2, when x is less than 0, then fx is equal to what? Minus x cubed. So f dash x will be how much? It will be minus 3x square. And f double dash x will be how much? By minus 326x. Okay. So now only the third case will be an interesting one for the simple reason that here on the right side of 0 the function is defined differently, that is x cube, and on the left side it is defined differently. So we have to be careful for the third case, and that is the case which we, as a matter of fact, this question has been given just because of this reason, that how you take up the things when the function is defined differently on the right side of a given point and on the left side of the given point. And this thing you have already seen in while taking up the questions of continuity also. When you were shown to, when function was defined differently on the right side of a given point and on the left side, then of course and you were to verify the continuity at those particular points. Then see, you find that that was to be done in a different manner. So here see, we will, case 3, that is a good one, when x is equal to 0. And when x is equal to 0. So please see, limit of this thing when x is 0. So derivative at this thing, we will try to find it out. Limit, so for finding the dy by this thing, dy by dx, at x is equal to 0. First of all, let us take the right hand limit. Okay, so limit h tends to 0. Okay, plus. Okay, and then what? f0 plus h minus f0 upon h. So this is limit h tends to 0 plus f0 plus h. This is fh. fh will be on the right side. It will be h cube minus f0, f0 is 0 upon h. So this is basically your limit of h tending to 0 of h square. One h will cancel here and you will be getting only h square, and this thing, so this is 0. This is 0. Because this is a polynomial, and in polynomial you are justified in a polynomial is always a continuous function. So limiting value there will be equal to its functional value. So you are justified in putting at 0 at place of h. Similarly, now for this thing, for finding dy by dx at x will be 0, let us see what it gives me on the left side. 0 minus, when x, not x, but x is tending to 0 minus. Okay. So here f 0 plus h minus f0 upon, let us calculate h. So this thing will fetch me what? This is fh minus, and h is here on the minus side here. So it will be minus h cube minus 0 upon h. So this is minus h square. And limit of course h tending to 0 minus. So this is, this limit again will be what? Limit s tends to 0 minus is equal to. So this is 0. Again see, minus will come outside and you are justified in putting 0 because you know this is a polynomial in h and a polynomial is a continuous function. So both ways, the left hand limit and right hand limit of this function, which is the derivative here. So what you are finding that yes, the derivative first dy by dx, because the left hand limit and right hand limits are equal, then of course it means that the
this what it is, dy by dx. Please see to it. Why I am calculating left hand and right hand limit, that also you need to be very clear about it. Because dy by dx here at 0 is nothing but f0 plus h minus f0 upon h, and limit s tending to 0. Limit s tending to 0. Now here when left hand limit is equal to right hand limit, then this means that both this limit here will, irrespective, here s tending to 0 is indicative of the fact that it can go on the right side, it can go on the left side of h. So this implies that this is the same and this should be equal to 0. So first derivative will exist and it will be 0. Now with this understanding, let us calculate the second derivative. Second derivative for this third particular case here, because you have to show that second derivative is exists everywhere. Exists everywhere. This is the question. Please read it carefully. It says that in question number 18, show that f double dash exists for all real x and find it. Means everywhere it will exist. So please see. So what we have just now found out is f dash 0 is equal to 0. Okay. So now f double dash this thing 0 we have to find it out. So for finding this thing, what this thing will be, limit s tending to 0, f dash, again see now what you have to find, 0 plus h minus f dash 0 upon h. Now here, since the function is defined differently on the left and right side, so this limit, for finding this particular limit, what we need to do is, we will find first the right hand limit and then the 0 plus left hand limit, and if they are both equal, then we will say yes, this is the required limit. And so here it is f dash 0 plus h minus f dash 0. This is 0, just now we have calculated, upon h. Okay, f dash we have seen, f dash on the right side is 3x square, so it is 3x square. And x is what? H square minus 0 upon h. Please see to it. And this is limit h tending to 0. Okay. F, the value of c, f dash x everywhere on the right side is what? 3x square. And on the left side it is b minus 3x square. So here we will use 3h square at f dash at h. H is positive here. So this limit is what? This is 3 h, limit s tends to 0, and then 0 plus here means 0 plus. So this is what? Again 0, and likewise limit h tending to itna f dash 0 plus h minus f dash 0 upon h. Let us calculate this left hand limit of the this thing. For calculating the second derivative at 0, we have to calculate the now left hand limit for this particular function, because second derivative will demand means this limit should exist. So f dash 0 plus h, what it would be on the left side? From here it will be minus 3h square. Okay, minus, and this thing you have earlier seen, it was 0 upon h. So this is what? Limit, and limit of course h tending to 0 minus. So limit s tending to 0 minus 3 into 0, so 0. 3 into 0, because you know this is a polynomial in h, and a polynomial is always a continuous function, and therefore you are justified. So both left hand limit and right hand limits are equal, therefore this limit also exists and this will also be equal to 0. So what we have shown that everywhere, whether it is the third case at x greater than 0, of course it was too simple, it is 3x square derivative, it is minus 3x square, and it is 6x, and it is first derivative here is 3x square, and second derivative is 6x. Here it is minus 6x, and 0 it is 0. So calculation here for showing that how the second derivative exists, you had to first of all calculate the first derivative. You have to show that at 0 the first derivative exists, and then see
you had to calculate this particular way. For finding that the second derivative, you had to calculate this particular limit for the left hand side and right hand side, and in both the cases you have to show that they are equal. In this particular case, it was 0. So this is how you are going to attempt the question number 18. It is a good one. It is a good one. Okay, because it employs your theory. If you can do this particular question, it means you are clear as far as your theory is concerned. Question number 19, please look in. What it says? Yes, please read it. Using mathematical induction, prove that d by dx of x raised to power n is equal to nx for all positive integers. Okay. So you have to show that d by dx of x raised to power n, this is equal to n x raised to power n minus 1 for all positive integers. Okay. So for invoking the induction principle, what we need to show is that first of all, this statement should be true for n is equal to 1. So for a statement to be true, what should happen? For a statement to be true for n is equal to 1, d by dx of x should be equal to what? 1 into x raised to power 1 minus 1, that is 1 into x raised to power 0, that is 1. And it is indeed, because you know d raised to power d by x is 1. So 1 is equal to 1, so P1 is true. So P1 is true. Now let Pk minus 1 be true. Okay, now let Pk n minus 1 be true. This implies what? This implies that derivative of x raised to power n minus 1 is how much? It is n minus 1 x raised to power n minus 1 minus 1, that is n minus 1 x raised to power n minus 2. This is given. So this is true, means it is given. And what you have to show, that d by dx of x raised to power n is equal to this thing. Okay, so now d by dx of x raised to power n. This is d by dx of x into x raised to power n minus 1. Now let us just take to this to be the first function, second function, and invoke the product rule. So what it is? First function into derivative of second, that it is given. This is n minus 1 x raised to power n minus 2 plus x raised to power n minus 1 into 1. So what it is? This x raised to power 1 into x raised to power this thing is what? X raised to power n minus 1 plus x raised to power n minus 1. So n minus 1 plus 1 is x raised to power n minus 1, 1 goes, it is equal to n x raised to power n minus 1. So this is what we have established very easily. So it was hardly much anything difficult therein. So this is how we can do this question number 19. That is based on the principle of mathematical induction, and this you have already done in class 11th. Easy question. Now please see what is this question number 20. Okay, question number 20, please look in. It is that it has been given that sine A plus B is equal to sine A cos B plus cos A sine B. This formula has been given. And you have to find what? Yes, you have to determine what you have to determine? Obtain the sum formula for cosines. You have to find cos A plus B. Okay. Sine A plus B has been given. This formula has been given, that this is sine A cos B plus cos B cos A sine B. Okay. This has been given. Now, of course, see, here A and B, let A and B be some function of t. Let A and B be let A be equal to phi t and B is equal to say psi t. Imagine in your mind. And differentiate with respect to t both the sides, then what you will get. Here see d by dt
of sine A plus B. Okay, and this way you will again get d by dt of what? Sine A cos B and plus d by dt of cos A sine B. Okay, and each of them are product of two functions individually, so that we have to take care. Now plus A plus B you will put say P, so this thing will give you what? D by dP of sine P. Okay, let me do it. Put here P is equal to A plus B, so dP by dt will be equal to what? It will be dA by dt plus dB by dt. Okay, so this is what this will fetch me what? D by dP of, this is how sine P into dP by dt. Okay. Likewise here, for this thing it will be d by yes, here you will put here A is equal to say something Q and B is equal to say R. Then you have to invoke it. So that we will do. See, first function, derivative of first function. So first we write sine, derivative of second. So d by dt of cos B, here you put B is equal to say something, or B you put it. So d by dB of cos B into dB by this thing. And cos B will give me what? Minus sine B into dB by dt. Okay. Plus second this second function, that is cos B into derivative of sine A. Sine A is to be differentiated with t, so put first you differentiate with respect to A, and then A is to be differentiated with respect to t. So this will give me what? Cos A into dA by dt. This is what I will obtain for this derivative of this thing. Plus here, derivative of this thing on the similar lines. What it will be? Cos A into derivative d by dt of sine B. So d by dt of sine B will be what? D by dB of sine B into dB by dt. And d by dt of sine B is what? Cos B into dB by dt. Plus sine B, second function, into derivative of the first. So cos A, d by dt of cos A, d by dA cos A, that is minus sine A, and it is dA by dt. Okay. So this is how you are going to get it. And this whole thing in one brackets. Now see, it is what? D by dB of sine P is what? Cos P is how much? A plus B, okay, into dP by dt, and in place of this thing what you can write is dB by dt plus dB by dt. Okay. And this will be equal to what? Please see. Now here, the terms containing the dB by dt you assemble at one place, and that of dVA by dt you assemble at two places. So these are the two terms which are containing this thing. So let me write it. It is cos B cos A minus sin A sin B, and this thing into what? dA by dt. Plus similarly, terms containing this thing dB by dt, these two terms. So here let me take dB by dt common, and let me see what I will get in. Again see cos A cos B minus sin A sin B, this thing, and what else? dB by dt. This is here. Now here, what is the coefficient of dA by, equating the coefficient of dA by dt and dB by dt both the sides, what we will get is, here the coefficient of dA by dt is what? Cos A plus B. Here what is the coefficient of dA by dt? This much of thing. And this is what? Cos A cos B minus sin A sin B. And likewise here, the coefficient of dB by dt is what? Cos A plus B is equal to what? Same thing you are getting, cos A cos B minus sin A sin B. So this is how you are getting both ways, you are getting the same thing. So this is how you will be doing this particular question here, finding the derivative of sum of a cosine function, that is cos A plus B, when sin A plus B has been given to you. So this is how, making use of the differentiation, you can find it. Let us see the next question here. Okay. Now, next question, let us see. For y is equal to something that in determinant it has been given fx gx, fx, then gx, and then hx, and this is what lmn, and this is what abc, and you have to show that dy by dx, y is this thing, so derivative you have to find it out. So there's no editor, it is very simple. So what you will get, mc minus nb, into fx, then what, plus gx. So it is what, na minus lc gx plus what else, hx, so lb minus na hx. So this basically is this thing. So differentiating with respect to x will fetch you what? Dy by dx. Here this is constant, hc, this is constant, this is constant. So dy by dx is nothing but same thing, mc minus nb upon f dash x, d by dx, that is f dash x, plus here na minus lc, and this is g dash x, and plus lb minus na and h dash x. And this is nothing but see this thing, dy by dx, you can write here f dash x, g dash x, h dash x, and then same thing, ln. This is nothing but the expression of ln abc. This is this determinant. This expression is nothing. So this is how you are going to prove it. Now, the last question here, let us take. Is last question, 23rd question. Here it is. Y is equal to e raised to power a cos inverse x. If y is equal to e raised to power a cos inverse x, and x lying between minus 1 and this thing, x is lying between minus 1 and plus 1, and it is equal to, both that is included here. Okay. And then you have to show 1 minus x square and what else, y double dash minus x y dash minus a square y is equal to 0. Minus a square y is equal to 0. Okay, so what we need to do is here, let us calculate y dash, let us calculate y. So y is equal to, so y dash will be what? This whole thing you will put t e raised to power t, its differentiation, so you will get same thing, a cos inverse x into derivative of this thing. So it will be what? 1 upon under root 1 minus x square with the negative sign. Okay, this much. This is your y dash, okay? And likewise here, so you can find the second derivative, let us find it. It is e raised to power a cos inverse x minus a, let me take outside, and it is a raised to d by dx of what? E raised to power a cos inverse x upon under root 1 minus x square. This is minus a you have taken outside because this is the constant sign. Okay, so this is the quotient rule here. So minus a d by dx. So what, in order to find this derivative, you will invoke this thing. So under root 1 minus x square is what? 1 minus x square. Under root 1 minus x square derivative of this thing, it will remain what? A same thing, a cos inverse x, and then derivative of what? This thing again. So it will be minus a upon under root 1 minus x square. Okay, and then what? Plus minus numerator here, PC minus numerator, let me extend it, minus, and then this is what? under e raised to power a cos inverse x and the derivative of under root 1 minus x square. Derivative of under root 1 minus x square will be what? Now, this is what? 1 minus x square under root this 1 minus t, so under root t, that is 1 by minus 1 by 2 root t into derivative of this thing, so that will be minus 2x. So it will be what? Minus 1 upon 2 root 1 minus x square into minus 2x. So minus minus will become plus x raised to power 1 by 2. No, it won't be minus here. Let me check it please. Minus denominator, numerator into derivative of denominator things under root 1 by 2 raised to power this thing. So it will be plus only 1 by 2 this thing and minus 2x. Okay. So this won't be. You can play with it. So it is minus 8. Let us keep it now. E raised to power cos inverse x also we can take outside common. So it is e raised to power a cos inverse x. Let me take outside. So what I will get is here, this under root will cancel and you will get here what? Minus a only. Minus a and then this thing is minus minus will 2 will cancel, minus minus will be plus, and this will be e raised to power a cos inverse x. You have already taken common, and then it is 1 upon x upon under root 1 minus x square. So this is your y double dash, okay. So this is your y double dash, okay, let it be that. And then what you have to show? X y dash, okay. Now let us calculate this value, 1 minus x square y double dash, 1 minus x square, and see this is also here 1 minus x square, 1 minus x square also coming here, 1 minus x square also coming over here, fine, okay. So d by dx a cos inverse x, this minus a is coming from where? It is coming from here, okay. So this is what you are getting here at place of y double dash, this much of thing. So let me further simplify it, if it can be further solve it. Okay, minus a plus x upon this thing, y double dash, 1 minus x square. It is, you are finding the derivative of this thing under root 1 minus x square into a minus a this thing. Okay, minus this thing, derivative under root 1 minus x square, this thing 1 minus, okay, it's fine. Okay, so 1 minus x square, let us see what it fetches me. I will 1 minus x square y double dash, let me see what it gives me. It is this 1 minus x square will cancel, and what I will get is here, please see minus a square e raised to power a cos inverse x. This term and this term will also multiply, this gets multiplied over here. So it is minus, yes, minus how much? Ax, okay, e to power a cos inverse x, and what else? Upon under root 1 minus x square, okay. Let it be. So this is the value of this thing. And please see what is xy dash. Let me see like this thing also, xy dash. Xy dash, so this is equation 1, please see, equation 1. Equation 2, xy dash, where is my y dash? This thing. So x into y dash will fetch me what? Xy dash is giving me what? E raised to power a cos inverse x and minus a x into x upon under root 1 minus x square. Okay, let this be. Ax, okay, yes, it's fine. It's very good. It is a square a cos inverse x, this thing. Xy dash is this thing. So, okay, and a square y is how much? Yes, good. A square y is a square e to power a cos inverse x. Okay.
So now see, from this term if we subtract these two, so this xy dash, please see, 1 minus xy square is this whole thing. Now a square e a cross inverse x minus this thing minus xy. So this minus xy will make it plus, and this plus will go with this thing, and this a square e cos inverse x will go this thing, and whole thing will become 0. So 1 minus x square y dash minus xy dash minus a square y is 0. So this is how you simply put up the values, you get the answer. So this is how we have finished our this exercise, miscellaneous exercise, and the entire chapter 5th. So next day we will take the application of derivative, your new chapter, and with the hope and expectation that you must would have understood all these things, differentiation. Now on Monday we will be meeting, and then see, I intend to take one test of you people here. I will be giving you sufficient of time, and then you get prepared on, be prepared on Monday or some other day. See, I will consult both Bhavya and Sharma ji, and we will conduct one test. Bhavya sir? Bhavya sir? Bhavya sir, are you here?
Yes, sir. Yes, sir.
Sir, Sharma ji, you are also here fortunately. Can we conduct test after this 5th this thing, or should we finish the entire first book and then we can conduct the test?
So first take one test of chapter 5, sir, and then start chapter 6.
Let us finish the first part, first book.